Hello, and today we're going to be looking at the second part of the Pi Lab. So in part one, you went through and you created a graph here, and you should get what looks like a quadratic graph. And today we're going to be talking about the second part of this Pi Lab, part two. We're going to be talking about these last four questions, this linearization part of it. And what linearization is where we take a data set that isn't linear, such as this radius and mass, and we create a linear data set. So you're going to want to calculate all of these radius squareds. And I've done that already for us. And then for number 4 on the graph to the right, we're going to plot mass versus the radius squared. Mass on the vertical axis, radius squared on the horizontal axis. As always, don't forget your scale, your label in units, and a title for your graph. Okay, so here I've gone ahead and graphed and plotted these points for us. Now note, you don't want to connect these lines because we don't know what's happening between these points. These are just discrete points and discrete data points that we don't really know what's happening between them. So next up, we are going to use a different color to construct a best fit line. So I've got green selected, and I'm going to go ahead and select a line. So I'm going to go ahead and redo that. Put one end up here, put another end down there. And with these best fit lines, the goal is that you really just kind of want to eyeball it and approximate it and just kind of see, okay, this looks about right. You want roughly as many points above the line as below the line. But in this case, we have a really, really good best fit line, a really good best fit line. So that's awesome. The next question, number 6, should the best fit line pass through the origin? Why or why not? Consider a mass of a 0 diameter circle. So a 0 diameter circle doesn't exist. Like, that is not a thing you could make. So that mass must be 0. So it makes sense that this point does pass through the origin. And if you zoom in here, you can see that in fact it does pass through the origin. Okay, let's look at 7. Follow the instructions provided to calculate the slope of your best fit line. Okay, part A. Select and circle 2 points that are on your best fit line. Okay, so let me get a yellow. Let me make a circle. I'm making circles now. Oh, that's so big. And I'm going to shrink it down. Oh, this is hard to see. Let me make it pink. That might be easier to see. Yeah, it is. Okay, so we have this point. Looks like a really easy point. And when I say easy, I mean that it goes through an intersection of these lines. It goes through an intersection of these lines. And then let me make another one. And let's go ahead and say, I'm looking for something else down here that looks super good. This one right here looks really, really good. So I'm going to use those 2 points. And I'm going to change that back to green so we can see it better. Okay, so we've got that. Now we're going to use the coordinates of these 2 points and the formula for slope, calculate the slope. Okay, so let me grab my pen. And let me change it back to pink. This point is the point 0. Let me get a text box. This is the point each one of these is going to be 1/100th. So this is 0.016, comma 6. And this point is going to be down here. It's going to be 0.001. And then each box on the vertical square is 0.4 grams. So there's our 2 points. and make those pink to match, just so we can be super clear about what corresponds to what. And now down here, we have, nope, I don't want to draw a line. Give me a text box. They're populating over here. Over here, this becomes our y2 is 6.000 minus our y1 is 0.4000. And our x2, in this case, our radius squared for the further point, the point on the right, is 0.0160. And our radius squared for this point is 0.0010. Okay, so we're going to find the fraction of those. And then you plug that into my calculator. 6 minus 0.4 divided by 0.016 minus 0.001. I get that is equal to that equals 373.33 grams per meter squared. Let me just do, that's what I get for this one. Okay. Now in this next video that we're going to make, we're going to be talking about how do we interpret that value and what that value really means. So I hope you tune in for the next video, y'all. Later.